Water erosion poses a major threat to the environment and to our soils, which has severe consequences for the economy and the healthy living. The impacts of water erosion are manifold and can be distinguished in on-site and off-site damages. A key element for a better management of agricultural landscapes in order to reduce those impacts is to understand sediment connectivity, or in other words, to understand how much sediment is transferred from one landscape element to another landscape element. For example, from a field to another field or from the field to the river. In this regard, the SCALE project within EJP SOIL aims to provide recommendations for managing sediment connectivity in various agricultural landscapes within the EU and for reducing the impacts of water erosion in those landscapes. In a first step, the SCALE partners conducted a survey to ask institutions in different European countries on how connectivity elements are implemented in soil erosion models with policy relevance. We received about 50 answers from 30 regions in 19 European countries and are currently finalizing our data analysis. And the first results indicate that connectivity has a rather inferior standing in policy relevant erosion models. But there is a tendency that more and more connectivity elements are implemented in those models, or that models are used that are able to consider connectivity elements better in their modeling routine. However, the results of our survey also revealed that quality data sources as well as spatiotemporal scales of environmental parameters used and parameterization strategies of these models largely differ from each other. Therefore, the next steps of our project focus on firstly screening where connectivity elements are implemented in the European, but also national and regional legislation. Secondly, how a better harmonization of environmental input parameters could be achieved that would provide a better comparability of soil erosion modeling outputs. And thirdly, how up and down scaling methods of both parameters and modeling results can be standardized for a better spatiotemporal representation.